All right, so this is lesson 4, part 2, and we're going to do some topics on focusing on arcpy and some things that'll help us as you move along that I want to reiterate that I feel that are very important. The first thing I want to talk about is the described data. Described data is really important, and we'll see why in a second. So I believe it was at 2.4, ArcGIS Pro 2.4, they introduced the da describe method. And what this function is, it's just like the traditional arcpy.describe function, except it uses standard data types to get back the information. So you no longer have this opaque object returning back to you where you don't really know what you're getting back. You just have a simple key value pair being returned. So it's a lot easier to work with the da.describe because you don't have to go and look up at what all the properties are, because the object is a well-known key value pair set that's easy to just go describe.keys and get this information back. So there's a whole host of information that you can get from the help documentation, which is posted within our notebook, but you can get started here and go to pro.arcgis.com and then just do describe-data, or you can just search for it. And it shows a wealth of various uses, and it shows all the different data types that you can get information about your information about. Okay, so let's go back. So let's see how it works. So what we're going to do is we're going to import arcpy and do from arcpy import env, and then we're going to also import da. I have a file geodatabase, and what I'm going to do is I want to know the various things that are inside of it. So we're going to use a simple for loop, so for fc in arcpy.listFeature classes, and we're going to be able to see what's inside our defined workspace of our file geodatabase. For each one, we can go ahead and we can describe that information and then delete it. I'm just going to delete the reference to the fc. And then at the end, I could go ahead and I can query one of those describes. In this case, I'm just going to get the keys for a random one. Actually, it's the last one in the list of the file geodatabase. All right, so we can go ahead and examine the keys by doing desc.keys and get back dictionary keys, which is an array of all the values that are in there. Next, we can go through and we can sort of interrogate them one-on-one and then see how the values are being presented. So we can say with our print using the f string, we can say f and then in squiggly brackets k, and which is our key, and then in squiggly brackets the dictionary, and passing in the key again, we get our values. So it says catalog path in, and then our path to our data set, FID set in none, so that means it doesn't have any, and so on and so forth. And it's just showing you that from this one function, without really doing anything, it gives you a sense, without knowing what's actually inside any of the records or rows, sort of what your data is about, because you can get your spatial reference, the field names, the field types, and it lets you prepare to handle this data efficiently without actually knowing what it is. So after we have that for our vector data, we can start working with our cursor objects. And the da module, just like the traditional arcpy cursors, give you the ability to search, update, and insert. To search, what you're going to get is you're going to get this read-only set of our data, and it's going to return for each row within our table. It's going to return back a single tuple. Now recall from lesson 1 and lesson 2, tuples are can't be changed, they're immutable, so that means this is a read-only operation, so there's no way you can modify that information. So let's take a look at our data. We're just going to go ahead, grab the first row, print out the field names, access the data using a for cursor, delete it, break, and all we did was get the field names. We could also print out the row. let's add that just so you have a sense of what this information looks like. Whoop. Oh, we deleted it. There we go. So see, here's the tuple. Notice we didn't specify the field names, we just said star. And our second field, if we look in the list, it comes back as a tuple of two numbers. And this is our XY coordinate system in whatever projection or coordinate system that our geometry is in. If you need, in order to get the actual geometry back, you have to put the shape token in there, which is shown here. And that means you would have to list all your fields and then append that to the end. And we'll see that a little later on. So one thing we can do is that combining cursors with our describe object leads us to some information that we need, especially when we're trying to list all the fields. And when working with table discovery, oftentimes the simplest things can seem difficult, like getting the list of fields. So important pieces of information to know are the object ID field and the fields themselves. So we can just do DESC and then bring back the key of fields. And notice they're field objects. But we could use list comprehension in order to solve our problem here and get our information in. So I'm just going to take every field name within there. But remember, we don't want to get geometry. So we want to say if field.type lower equals geometry, if not equal to geometry. So that means we'll get a list. We'll get a list of all our fields that don't have the word geometry in it. But we'll see later on why that's important. The next thing that's really interesting, and I find it interesting at least, is that you have the ability to explode points. You can destruct your features into individual points based on their vertices. When you have polygons and lines, this would be, or multi-points, this would be applicable. So we're going to take the feature class that we've been working with, and we're going to pass in this additional thing here called explode to points equal to true. And we're only going to request one record here. So the second, where object ID equals 2. And let's see what we get. So from that one object ID 2, you can see that you get all these extra records, and that's because you're getting each vertices on this. And you can use this information in a lot of different ways. You can use it to sort of create triangulations between the various points within your data set. You could take it and you could take this information and you can build spatial weight matrices or do distance calculations, create graphs out of your points very easily because you know the XY coordinate of every vertices, and maybe transform it and pass it on later into a deep learning algorithm, stuff like that. It could also be very helpful. You could take this information and maybe do some sort of clustering with it as well. So it's another way to take your data and easily transform it and use it in other operations down the pike. Another helpful tip, I can't say I came up with this, but what I did is I was able to, I got this from some fellows on the arcpy team, and that's returning your information as a key value pair. So before we were getting our information back as dictionaries, as tuples, but we didn't know what the field names were. So using the trick we showed before, we're going to assemble our fields, but we want to actually get back the whole actual shape geometry in this one. So we're going to get every field except our geometry and then append the shape at token so we get back the actual geometry object. We're going to use our search cursor again and pass in our explicit list of fields, same where clause, so we're going to get the just a single row, and we're going to set explode to points equal to false. And this time we're going to see the difference of how we get our row dictionary back. So for each row in our cursor, which should be one object, we're going to use this little syntax here. We're going to take advantage of the built-in zip, and we're going to map our field names to each value in the tuple, and then we're going to convert it from zip to cast it to a dictionary, and then print out the results. So let's see what we get. We get our key value pair as expected. So we have our key, colon, our value, and you can see now it's a lot easier to see what we have within our data set, and it's easier to access that information instead of accessing by index number. Another interesting thing is the OrderBy. So sometimes you want to get your information back in sorted order. And in order to do that, you use these OrderBy commands in the section called SQL clause. So in this example with our search cursor, we're going to give it our dataset path in the fields, where clause, so we're going to get 3 different records. And then we're going to sort it by shape length. So we say, notice the syntax here. It's not like passing another where clause. You have to pass in a tuple. Where in this case, because it's a file geodatabase, we're going to just put none, comma, and then order by, and then the field name. So let's see what happens here. I'm going to create my dictionary create my rows as dictionaries, and then print out the results of each shape length to see if it actually put them in sorted order. And we can see that we did order by, and we went from default, we're going ascending. So we have our smallest, next smallest, and then our biggest. And you can specify the sort order to be ascending or descending as well. That won't work on shapefiles. Just wanted to let you, that's another caveat. Another thing that I find really interesting is and helpful is that you can do on-the-fly reprojection with cursors. And this works with both search and update cursors. So what we're going to do is we're going to look at our information again, and we're going to see that we have our original WKID here. We're going to pull that from the describe. And we're going to go ahead and say, I don't want my geometries to come back as the defined geometry. I want it to come back in WGS 1984 or WKID 4326 or lat long, if you don't know what the other two were. And so when we go and look at our geometry from our shape at, we can see before, let's see, when we go up to the exploded points, we can see that we had our points, they looked like this, whatever number this is right here. So for the second object ID field. So let's take a look at how they look. So our first record that we're going to get is going to be that 2 field, and we're going to see that our information is going to come back in a different factory code than from before. So we're going to go ahead and let's print that out and see what we get. So we originally were in 2226 or 2226, and now we're in 4326. And we can go ahead and let's try to take our geometries and see if I can do this on the fly. Shape at, let's do something simple. So we can see that we took our point and reprojected it. And notice that we do fall within the coordinate system of WGS 1984, latitude, longitude, right here. And we can see that each point is appropriately shown. Okay. Now, what we saw before, all that other information can be applied to update cursors. So with update cursors, not only can you modify the rows, so the information that you get is mutable, it can be changed. You can also do all this on the fly reprojecting and the SQL clauses with the sorting and everything like that. And what we're going to do in this example is we're going to, before we saw how to read with dictionaries, but wouldn't it be nice if we could write with them as well? It seems very more intuitive to me to do this. So what we're going to do is we're going to go in, here's our feature class, and define a function. And the function is going to take our cursor objects, or da.Update cursor in this case, and we're going to go through and do for cursor, and we're going to create our row object, and then we're going to use, instead of a return, we're going to do a yield. And then then we're going to go back and we're going to update it by casting it, taking the values and sort of stringing them back out and then passing them into that update cursor. And what we'll see is that we're going to change our city name, which currently is all lowercase. We're going to capitalize the first letter in every one and update our city name to the proper way it should be written for our world cities. And you can see we went through and we were able to update everything. You can see for this one, every word has a capitalized letter. San Fernando, there we see them all the right capitalizations that we expect. With our fields, we saw before we can print out the various types. So we have OID, geometry, string, small int, double, string. In this field, this is what we in this data set that we've been working with, this is what we have. We can go in and delete information directly from that. But it's good to know when we're setting up criteria where things should be erased, what data is expected. So I can quickly glance that and see if I were to do something probably even a little more interesting and do field name and then the D type, and then we can see that object ID is an OID, or shape is geometry, etc. Wet is a string. Okay, so we're going to go in and we're going to capture our deleted rows, and we're going to get our fields, explicitly set it, and we want to get the actual geometry. We're going to say with update cursor, pass in our information, get a update rows, cursor object, a uRows for our variable. And then we're going to say if the value is 0, in this case, it's going to be our object ID, do mod 2 division. So if it's even and it's less than 10, then we're going to erase it and delete the rows. Let's see what happens. So we erase 0, 2, 4, 6, and 8, because 0 mod 2 equals 0. So we got all the rows that were expected and they were deleted. We can then go ahead and interrogate them, and we can even put them back in. So if we wanted to, deleted rows, we can see what we have. So this is the information that we erased within our thing. So we could turn around and we can insert that back in. So what I'm going to do here is for each one of those rows I erased, I want to put it back into my data set. And I'm going to get the count for the current feature class, create an insert cursor, add the rows back in, and then print out the count again. So we can see that we have 2,466, and then we added our rows back in, we have 2,471. So it did the insert. Now for those who don't know, the reason we use the with all the time is because when you're done doing a cursor, you want to make sure that data is freed up for other individuals, because it puts this thing called a lock on our data sets or our tables. And to get around that, let's say you're in a multi-editor editing environment or a file geodatabase, we can use what's called an editor. And the editor class is going to manage our transactions for us. And it's going to temporarily, and this information is going to be temporary until you save it and you explicitly say that it's permanent into your data sets. So that means you have options that are undo and redo, and it'll allow you to let multiple people edit the same data source at once. If you make a big mistake, all those transactions can be rolled back. So you don't have to constantly be copying your data and putting it in folders while you're doing your operations. You can take advantage of this editor object in order to do this. So there's some things that can only be edited within an edit session, and these are topologies, geometric networks, network data sets, enterprise geodatabases that have versioning, and some other stuff as well. And so we're going to go ahead and do an example of using the editor, and we're going to create a unique value count with the value of this watt wet, and then we're going to display the information to the user, and then we're going to go ahead and remap some values with a predefined set, because for quick glances at our information, the labels are too long. So here we're going to do some basic imports. We're going to import OS, DA, and ENV. We're going to set our overwrite output to true and define our remapping. Once we have that, we want to get a unique set of values. We're going to define a set. If you recall, a set is a piece of information that can only contain one instance of something. It can have 0 to n objects, and you can add information and remove information from the set. And the benefit of this is when you're creating unique values, like in this case, they're a lot faster for lookup. So if you have a list and the lookup in a list can be to the O to the N, so it's linear, so it has to go through every item before it determines if it doesn't have it. A set does it in constant time, so it's quicker. So here we have our unique set of values with our value count. We have a feature class where our data is. We're going to create a copy for what we're doing for this short purpose. Copy our data, add a field to it, start our editing session, and we're going to take advantage of using an update cursor in this case to not only walk our data, but to also update the values when it meets some criteria. So we're going to go ahead and we're going to get the index for our short name for row in ucur. If row 0 is not in unique values, we're going to add it. We're going to remap our values, do the update, and then if the value is in the value count, our dictionary, we're going to add 1 to it, else we're going to create a new entry. So let's go ahead and collect our information that we need. It's going to take a second to run, and it completed. So now we've captured a bunch of key pieces of information, our value counts, we've remapped our data set. So let's take a look at this. I'm going to import matplotlib, which has been in the ArcGIS platform for quite some time, and then display it. So what we're going to do is we're going to create a bar chart with the labels as our keys and the value and the height of our bar charts from the values of these counts where we kept adding 1, and display it. So what we see is the number of instances where they encountered this type of data, and we can see that we have a lot of freshwater, herbaceous wetlands, and woody riparian data, but we have very little tidal salt marsh, water estuary, water laguna, etc., and water ocean. So there's only one instance of the ocean. And then we have water lake reservoirs that are kind of medium, and water rivers. And you could do other information with this as well, and you could sort of save it as images. You could export this image once you have it. We're going to go further into visualization, but this is just a nice way that you can sort of wrap all the concepts that we've done up until now and show how they all work together. All right.